Hello and welcome to day 34 of daily Leetcode challenges. Let's begin our question. Okay. Question 45, jump game 2. You're given a zero-indexed array of integers, nums, of length n. You're initially positioned at nums 0. Each element, nums I, represents the maximum length of a forward jump from index I. In other words, if you're at nums I, you can jump to any I plus j. You can jump to any I plus j, where j is smaller than nums I, and I plus j is smaller than n. Where I plus j is smaller than n. Returning the minimum. Okay, so without these conditions, it seems to me like in each of the positions of the nums array, there is a jump, meaning the jump. What I mean by jump is how much from the current index you can jump ahead. I don't know what this j is talking about here, what j refers to, because it seems like j plus the current index is smaller than n, but I see here that 0, 1, 2, 3, 4, the index 4 plus j is definitely not smaller than 5, so a little bit confused about what what's saying here, but let's look at the examples maybe. Okay, well, hold on. Return the minimum number of jumps to reach the last element. The test case are generated such that you can reach the last element. Okay, so first of all, there are no cases where you can't reach the last element, and we actually just have to be in the position here. Output 2, because you start from here, your steps 0, you travel to one of these two values, probably going to travel to this one, and after this one you're going to travel to one of those three, last being one of those options, so it's 1 and 2 essentially. Okay, minimum number of jumps to reach the index is 2. Jump 1 steps from index 0 to 1 steps, then 3 steps to the last index. Okay, let's think. How does so as I'm walking through the array, as I'm progressing through the array index by index, I essentially have some number of jumps, some number of free steps that I can take ahead without considering this as a step, right? So let's say that I am at the 0th index, and I'm at the 0th index, and I have some number of free steps. Let's say that I have 4 free steps. Well, me taking that offering of free steps actually means that I've taken a step, so it would mean that I took 1 step to get to the end of the array, if this was, for example, 4, right? Because I would be, so what if we essentially what if we have an array called min steps to reach, min steps needed of length of the same length as nums, And as we go through each of the indices of this nums array, we step ahead the number that we're looking at, the jump that we're looking at, and paint or replace the min steps needed value with that new number of steps needed to reach that index if the current proposed min steps is less than whatever is placed in there. So what I'm let's call this min steps needed, and this is going to be an array of basically the maximum amount of steps needed to get to that point. So it's going to start off with just the length nums, which is the maximum, and now let's say that, how should we look at this? For I guess what would this be? The current position, the current let's say step, the current step, and jump in enumerate nums. So we're going to enumerate the list nums. The current step is going to indicate which step we're on, worst case scenario, and the jump is going to tell us how much we can actually jump. The proposed min step is equal to the current of the current, let's just call this pause instead, position, plus, now what would this be? The current plus 1, where the min steps needed of 0 is actually 0. So if we're standing at the 0th index and we want to predict or to fill in min steps array, however, dictated by, if we want to pre-fill the min steps needed array with the number of min steps needed to get to these two values, we would say for, let's say, step in range jump, right? We are saying that we need to look ahead inside of this array and basically say that min steps needed at position plus step is equal to the min of the current value and the proposed min array. Print min steps needed. Steps needed, index out of range, turn min steps needed -1, the last element. What do you mean by it's out of range? Let's see, we are looking at the current, index. We are at index 0, and we have a jump of 2. If we have the ability to get to the next 2 steps in this value plus 1, so we initialize the proposed min step as the current number of steps needed plus 1, and we say that the min steps needed to min steps needed to get to the next. Oh, you know what I might be doing? I might be stepping over the. So in this case where I'm actually looking, I guess, over to something longer than nums, I should say that the position plus step should be smaller than L, which is the number of. Let's run that. Okay, so something is going on. We are not. Should this be +1? Because it should be +1 because we, okay, so how should I, so next pause is going to be equal to pause plus step and +1, and next pause is going to be equal to next positions index is going to be equal to the minimum. Still no. So we're okay. As usual, let's just think through this slowly. We have a jump. We have an array of minimum steps needed to get to that current index. We populate the first index to the minimum steps needed to get there, which is 0. And we say that for the rest of the array, the way that we're going to figure out how many steps minimum needed to get to the last element is we're going to look at every jump starting from the 0th, say that we have a position representing the current sort of the current step, I guess, the current step in the worst case, which is just pause. No, this shouldn't even be the worst case. This should just be pause as in like where we are in the array, right? We're pre-filling the array with minimum steps needed to get to that point, so this is just a position inside of this min array. So we have the position and then the jump. We say that the proposed jump is equal to the proposed min jump is equal to the current min jump plus 1, right? Plus that 1 step. And so for steps in range jump, which is from 0 to 2, no, from 0 to 1, because it's not inclusive, we say that the step is equal to position plus step plus 1. So next jump is going to be position, whatever position, plus 1, and then plus 2, because the first step is 0. Then we say if next position is smaller than if next position is smaller than L, which is the length of nums, then we fill the next position with the minimum of and this is where I went wrong, the minimum of next pause and proposed min steps. Okay, sweet. It's taking a while. Okay, so this is clearly not good enough. Shoot. Okay, let's see what. Actually, before looking, let's see if we. So, I understand that this is basically an O(n) squared solution because for each jump we're looking ahead and seeing if we and basically pre-populating that array. What if somehow we kept track of the minimum, or not the minimum, we kept track of the step that we're currently on, and then we figure out when exactly we need to switch to the next jump. So okay, so yeah, so I'm trying to think of a way to solve this more dynamically, where to the next step, the next index that we're observing, we essentially already have all the information needed to figure out one, how many steps are needed to get to the current place, and what else do we need? We need the minimum steps needed to get to the current place, and all the information to tell the next index what is the minimum number of steps to get to that place. Okay, we probably need steps for that. Let me basically scrap this. Steps, right? We need the current steps. We need the probably the max jump. We need the max jump because the max jump to basically know which one of these jumps to pick for our next step, and we need to somehow figure out where our current end is going to end. Let's say that for position in range, I have L. We're going to say that max end and cur end is equal to 0. Cur end is equal to 0. We're going to say that max end is equal to max of max end and position plus nums pause. Right? Because we're looking at the current position that we're at. We're looking at the current position that we're at, and we're trying to figure out what is the max possible jump that we have at our disposal right now. Currently, when we're looking at this position, it's just the current index, which is position, plus 2, which leads us to this 1. That's our max. And then if we say that if current end, which is currently at 0, is equal to position, that means that we have already reached our current limit, and it's time to switch over to the next max jump. So then we can say that the current end is equal to max position, which would leave us at these next two indices at our disposal. And let's say that the steps plus equals 1, meaning that we have actually taken this step. We've taken this step, and steps. Okay. Let's see. Wrong. Print step. Print. Let's actually look at what do we care? We care about the steps that are needed at each index. So, okay, so at the first case, it should be 0, right? We need 0 steps to get there. At the second, we need 1 step to get there. At the third, we need does this just print? Okay, so this is all correct. So at the first index, it takes us 0 steps to get there. At the next two, it takes us 1 step each to get there. And for the next why does this say for the next only? Oh, for the next 2, it takes us 2 steps to get there, which is correct. So the 3 is getting returned because we're observing this as a. So do we not care about this jump at all? If we don't care about this jump, this is an easy fix. Okay. Okay, awesome. This beats 45%, but let's see. Let's just this is not ideal. Only beats 48%, but I'm thinking that is it because of the print statement that I have there? What if I remove the print statement? Because literally anything can cause this to be slower than supposed to. Let's see if this is a little bit faster. Okay, 97. Sweet. The difference was just the print statement. Okay, feel free to use this solution. Both the solutions, the previous one I'm talking about, it has the right idea, but we could have provided all the information needed to make the decision of what steps are needed without pre-populating the array. So yeah, use this one. This is better. Thanks for watching, and I'll see you later. Bye.